Now, very quickly, try to draw a hexagon. Okay. Now, a hexagon will have certain inputs. So, for example, point O is 0, 0, and I'll have theta1 as, let's say, 0. I want the first edge to be horizontal, so that is theta1. Okay. Now we want the length of the edge. I'll have L. Please remember it is L and not 1 is equal to, let's say, 4 units. Okay. Now with respect to O, point A will be somewhere here. So the length is known, which is 4, and the parametric equation, if I draw a circle here, 0.4 is on the horizontal, so theta1 is 0. So what we'll have is AX is equal to L into cos of theta1, AY is equal to L into sine of the 1. You may argue, why did we actually do it? So the reason being, if we don't want the first edge to be horizontal, what if we want it to be 45 degrees, right? So then we'll be still able to draw the hexagon. That is why we are using parameters, variables in the beginning and making use of those variables down the code. Now point A is AX, AY. Okay. So we have drawn point A. Now point B will be somewhere there. And since it is an hexagon, the angle here will be 60 degrees. Okay. So we need BX, which is AX plus L. Oh, sorry. Now I need the angle that is 60 degrees. So we'll start using theta2. Theta2 is equal to theta1 plus pi by 3. Okay. So theta1 is, sorry, theta2 is dependent on theta1. If the first edge is like this, theta2 will be dependent on that. Okay, so we have theta2 value, which is approximately 1 radian. Yeah, that is what it is, 1 radian. Because pi by 3 is 60 degrees, 1 radian is around 57 degrees, so it's almost as 1 radian. Okay, now we want to find coordinates of point B. I'll write Bx is equal to x coordinate of point A. So basically now I'll be drawing a circle here centered at A, and at 60 degrees I want the point B. So coordinate of B is AX plus BX. BX will be this much. So it will be AX plus, now the length is the radius, basically L into cos of theta2. Please remember it is theta2 now. Okay, so that is BX. Similarly, BY is equal to AY plus L into sine of theta. Okay, so we have got the values of BX and BY. So point B is obtained by giving those parameters BX, BY. Okay, so next point B is obtained. Similarly, we'll have to obtain point C, that will be somewhere here. And the angle that BC makes is 120 degrees. Please remember the angle in circle representation is always with respect to the positive x-axis. So we'll measure the angle with respect to the horizontal positive x-axis. And now it will be 120 degrees. So I'll write theta 3 is equal to theta2 plus pi by 3. So I'm just doing incremental because everything depends on the first angle. Okay, now theta3 value is gone. So if we draw a circle with respect to center B, the x coordinate of B will be used plus L cos 120. Okay, so numerical value will be negative. So basically there is a higher value and then negative value. So that is why we'll get point C somewhere there. Let's look at that. Cx is equal to Bx plus L into cos of theta 3. Okay. Similarly, Cy is equal to By plus L into sine of theta. I'll get point C is equal to Cx comma Cy. Okay. So we were able to get point C. So similarly, we can have theta 4 is equal to theta 3 plus pi by 3. Dx is equal to Dx plus L cos of theta 4. Dy is equal to Cy plus L sine of theta 4. Capital D point is Dx comma Dy. Okay, so it's closing the loop. Similarly, we can get the point E. Before that, let's have theta 5 is equal to theta 4 plus pi by 3. Now Ex is equal to Dx plus L into cos of theta 5. Ey is equal to dy plus L into sine of theta 5. Okay. Now E can be obtained as Ex comma Ey. Right. So we have all the points. We just need to get the segment. Segment OA is equal to segment between O and A, that is drawn. Similarly, segment AB is segment between capital A and capital B. Segment BC is, please remember to use the syntax correctly. If you make typing mistake, then something else will come. Let's say segment CD. Instead of using capital S, if I use segment and then try to do this. Okay, maybe there's some intelligence there, but sometimes it doesn't work, so you have to be careful. Segment DE is equal to segment between D and E. Similarly, segment EF is equal to segment between E and F. No, there's no F there, sorry. The name also, I'll just make it. Okay, so this is how we have drawn a hexagon using program completely. Now what will happen if I change this theta value? If I use this is in radians, so theta 1 is, if say pi by 3. Something happened. What happened? Yeah, so it basically rotated OA. Point O is still the same. So if I give pi by 4, see that it is OA is making 45° with respect to horizontal. Everything else was same. Now let us use this as 0. Now what if we wanted to translate that and maybe center of this or maybe here? So what we'll do is I'll have to, yeah, this is another problem. I did not have take that A is dependent on point O. Okay, now this is the problem. So I tried to make it 2, but rest of the points are same. Only point O moved because A did not move with it. Now why? Because in AX we assume that O is constant. Okay. So instead, what you should have done was x of O. So this is another way of retrieving data of O. O is a point. X of O means x coordinate of O. When I do it, you see it moved. Similarly, we can have y of O. It's a good thing that we missed it. So y of capital O plus L sine theta 1. Nothing happened here because O did not change. Here, if I have 5, point O will have coordinates 2, 5. That is what is the drawing about. Okay. So the students are expected to define all the variables in the beginning itself, whatever they are going to use. So for example, theta 1, theta 2, theta 3, theta 4, theta 5 should have been defined earlier. And as and when the code comes, I mean, they write, they should be able to use those variables in the further line. If at all there is any mistake, you can just delete that particular line and then start fresh from there. So since this is a free software, let's respect that there are few shortcomings, but nevertheless, it is very good for teaching purposes. Thank you.